pressure system. And this is the product that you can see here. I'm going to do not too much of a deep dive into it, but just a snapshot of what this standard is, what the technology is, and what it means to you. So I'm going to take you through the journey of our UL2166. Don't worry, I will explain what that standard is and what it means. But doing this standard is quite familiar to a lot of people at this show at this moment, and they will understand that there's a lot of time, resource and energy that goes into achieving this. However, what we've managed to achieve is a world's first, which means that there's a lot of differences that we've had to do and implement into gaining this world's first approval. So the journey looks like this. What is UL2166? What are direct DLP systems? That stands for direct low pressure. Why did we choose UL2166? How we achieved it, and why is this important? And that is why it's important to end users, distributors, and manufacturers. So we're going to start going through what UL2166 is, and UL stands for Underwriters Laboratories. It's a standard for halocarbons, clean agent extinguishing system units. And when we mention halocarbons, this means a clean agent which has typically would have a bromine, chlorine, or fluorine or iodine element in there. However, at Reacton we use Reacton 1230, which is a truly clean agent where it has no ozone depletion potential, global warming potential. It's completely clean. It doesn't leave any residue. It's non-corrosive and is perfect for the applications that we use. Going back to the UL standard, it applies to the construction, the performance and the testing of this extinguishing system. It's put in line with NFPA 2001, and this is what was pivotal to getting this approval. These units are used for total flooding. That means that an agent is introduced into a volume at a specific concentration and it puts out the fire there. They work in a little bit of a different way than some people might be used to, such as dry powders and water mist and those items. Clean agents work at a molecular level. They take the energy out of the fire to a point where the fire can't sustain itself. So they're completely non-toxic. It's very small on there, but non-toxic. They're safe for environments for people in there. There's minimal damage. So as I mentioned, there's no cleanup. They don't have water in these products, and they don't contain any particles. So there is zero cleanup after these go and discharge and put out fire. I mentioned here the no cleanup that we have on the clean agents. Minimum downtime, because it's acting very fast, it's very effective in the Class A, B and C fires. You have minimal damage. There's no big cleanup operation. You haven't lost that sensitive electronic item because it's had water in there or powder with fine particles that you need to clean up. It is change the path, had the issue and caught fire, get it back up and running in minimum amount of time. Everyone understands the importance of no downtime or minimum downtime. And as I mentioned, they're effective for Class A, B and C risks. Now we've mentioned what UL2166 is, we need to know what are DLP systems. As I mentioned, these are direct low pressure. And these are a system where, I'll show you a video here, which gives you a real nice sort of objective view of how the product works and the simplicity of the technology, but the performance and power it can provide. So it essentially works where there's a radiant heat of a fire, this bursts, and the system, which is in communication with it, delivers the extinguishing source where the fire is and extinguishes it. So it's detecting and extinguishing at the point of where your fire is. And effectively, your detection tube is an effective detector and nozzle wherever that is routed. So it isn't a point detector, it's a full length of that detection tube. It acts as a detector, as you can see here, and discharges the agent. And the agent is specified to fill up the volume and achieve that concentration. Again, we have massive safety factors on the product that we use in there. Normally a clean agent, which we use the Reacton 1230, which is traditionally known as FK5112. That has an extinguishing concentration of 3.5 for Class A, and we're designing these at about 6 to 7% concentration. There's massive safety factors. So as I mentioned, the detection method is a proprietary nylon polymer tube that we use and needs to be made extremely accurately. And this tubing is routed around the wrist. Wherever there's high heat, radiant heat or a flame, it will burst, discharge the agent. They're all pre-engineered. When I say pre-engineered, this is a term that we use in this industry for products that have all the testing done up front, and as long as you design it in accordance with your technical manual, you can install it without having to do any complex design work, hydraulic calculations and verifications. It's low weight, there's no moving parts, extremely compact, so these can fit right next to the hazard that you have. Completely pneumatic, so this is an important one which a lot of people would understand that if you have to have a fire extinguishing system, you need power. You need to power your control panel, your detectors and sounders. This requires zero power, completely autonomous on its own, and it can be right next to the hazard. So this is a big selling point for this technology. And as I mentioned, it's an effective discharge nozzle wherever the tube is routed. And a huge advantage for the detection tube is it's not affected by smoke, debris, dust. You're not getting the false alarms. So this is why this is the go-to product for certain environments. So minimal false alarms is what everyone wants to have, but you've got that absolute backup that if there's a fire, this is going off and it is going to put it out. So that is a real core part of this technology. And I've shown you a few examples there of the product in situ and obviously what was taken out by design manual. Why did we choose this? So everyone understands that there's standards out there for fire extinguishing systems, but there's a big absence of any globally adopted and recognised standards for the testing and installation and design of this technology. So we needed to do that. People who do total flood systems are used to designing a system in accordance with the standards that everyone knows for the total flood systems, such as ISO 14520, BSEN 15004, or NFPA 2001. That doesn't cover this technology. There wasn't a standard that covered it all. So we wanted to use those references to be able to create this standard or product. So I wanted the product to follow the technology for total flood clean agent systems, as I mentioned, that they're designed to those design standards. And why should this technology differ? People are used to having product installed and designed to that standard. Why should this differ? We can achieve it, and we have done. I want to bring this technology up to the latest level and what customers expect. Just because it's not been innovated, that doesn't mean it shouldn't be, and that's why we wanted to make sure that we kept driving the industry forward with pushing what's expected of the technology. Everyone will have peace of mind that this system is designed, look at this. It complements our other technologies which have this approval, but also allows us to protect larger volumes than some of the other standards that are out there for this sort of technology. So I thought I'd put this slide in here because if you've come to our stand today, you would have seen maybe a little logo or a badge next to this system, and everyone thinks that's what's involved. And it's, there you go, there's a certificate, that wasn't too hard, it's quite easy to do, but what actually goes on behind the scenes and underneath that is the research. There's a huge amount of pre-testing that we had to do, all the flow analysis. We needed to make sure that this product could discharge in the 10 seconds or less, which is a requirement of this standard, whereas previously that wasn't a requirement. We had to come up with a concept, we had to build that, prove that technology, test and evaluate. Documentation takes up a lot of time. We need to make sure that the evidence is recorded. This goes out to UL and they can understand your product clearly. Component testing. I'm not going to bore you and go through the details of every single component test in UL 2166, but it's huge. I will cover a few of them, but there are so many component tests that push the limits of what's possible on this technology to make sure it works when it's called upon. Fire testing is a normal part of any standard, and someone being able to achieve a listing as this. But we had to build those test bricks. This was new and innovative. So enclosures and methods had to be designed, it had to be repeatable and compliant with the verification from UL. This was all witnessed as well, so there's a lot of things that will have to happen. We have to review all of this as well with the certification body and the manufacturers. And then, as we all know, testing and approvals cost money, but it's the time and the resource for people to be able to achieve this. Collaboration from the teams involved, very lucky to work with some of the best minds in this industry, and very privileged to do that. But the fees can mount up if you're not doing this in the most strategic way. So what we're going to do here is go through some of the bit more of the details of how we achieved it. So there's performance tests that set out in this standard that we have to do. They have to be repeatable and accurate, and prove that this technology can meet the harshest requirements in these standards. But there's a huge list of those component tests that I mentioned earlier. Some of those are one-year leakage tests, which you see the products down the bottom here. These products go into a lab. It's a controlled climatic chamber that is kept at a monitored temperature for 1 year to look for leakage. It can't leak to a certain amount, but you can see some of the investment we do up front there to make sure that we're future-proof. Because what we're doing at the moment isn't the end for us, it's just the start. So there's many other things in the pipeline for us to make sure that we keep innovating. But there's a huge amount of resource and time and effort that goes into these tests. And then you have items like corrosion, you have hydrostatic tests on all of the components. There's cycling that goes on, 500 cycles on every device, air oven aging, elastomeric UV and water tests, just to name a few. Then you have all the fire tests. There's quite a few that we had to do. And again, this technology is trying to do the same sort of tests that you would have on a total flooding system, but this is a small compact system being delivered through a 6mm tube. So it is extremely tough. But I've got a few videos here so you can see some of those tests. The first one that I've got that comes up here, this is section 37.3, it's a nozzle distribution extinguishment test. And we have 10 cans in there filled with heptane, and they're mounted in strategic places. You have a baffle and you need to be able to put them all out. This standard requires for full extinguishing. There's no allowance for I managed to get a certain number put out and I average that and I'm okay. It's full extinguishing. And then we have another one here which is the automatic extinguisher test, and that is the pan at 0.23 systems that you see that are tested there have the biggest length detection tube on there. It also has the lowest expected temperature, so you get the lowest pressure in the system. So it's minus 20. It comes out of a climatic chamber at minus 20. It's attached, then you discharge the system in its worst possible setup to make it as hard as possible. So you need to put those fires out within 30 seconds of the end of the discharge. Why is this important? Moving away now from the real detail of the test and the standards. It's commonplace. Total flood systems have UL listing. It's globally recognised. People are used to having that. And now we can have the direct tube technology, or DLP, approved to the same standards. So we're able to now further enhance the protection for your asset using the UL listing. It's a trusted name. UL are been a trusted name, safety and science, for more than 125 years. They've been brilliant to work with, and we've got a lot more projects going on. But everyone just knows that logo and that symbol, and they just associate that with quality. And that is what we want to be associated with. It's a step forward as well. Platforms like this are great for showcasing the technology, but being able to show that direct, the tube-based systems that we're talking about here can provide high performance. They can be held to the same account as a total flood system, and we can work in harmony with total flood systems and offer protection. So that's something that we're really keen to try and educate the market on. It's a flexible, pre-engineered system, as I mentioned before. There's no complex design work that you need to do. As long as you install this system to your technical manual and you keep within the limits, you have a UL-approved system. This is what customers want to have. They want to be able to install these systems extremely fast but accurately, and we're giving them all the chances for that to succeed. And one of the other parts why this is important, we're a global company, and we work in many territories where previous sort of approvals and standards weren't recognised, and it actually stopped us from being able to sell that technology into that market. UL is on all of the global laboratory lists and everything like that, so it allows you to be able to have this technology accepted. We're really looking forward to growing the knowledge about this, and we're hoping that the industry follows suit and other manufacturers look at this approval as well. So that's a very quick summary of the products that are involved in this approval, but also details of how we achieved it. It's a very simple product, and if you see it on our stand, you can be excused for thinking that there's not much that goes on behind the scenes to be able to achieve an approval, but there is, and it's held to the highest account, and there's a lot of time and energy that goes into achieving these approvals. We want to be transparent, share that information, that knowledge, and make the market understand that they are systems that can protect the smallest of assets safely and with high performance. So really thank you for your attention for this short presentation.